Welcome back, pre-calcers. What we're looking at is going to be the sum and difference trig functions that we've seen in 5.2. These definitely need to be in your notes to be successful with the quiz for tomorrow, and you definitely want to make sure you understand every little thing that's going on here. So originally in the 5.2 video, we saw that these functions were introduced, and instead of A, they were using alpha, and instead of B, they were using beta. But it's still the same context here where we have two different trig functions. We're trying to combine these into just one function and trying to take that further. So we'll see that we use the sign of alpha plus beta. We also see if we're taking a difference with alpha and beta when we use sine, also cosine, and for sum and difference. So this is 5.2. These equations are going to be helpful. I'm going to be using these sporadically throughout this video. So if you get stuck, make sure that you have these down. As we take a look at the first problem, this one is pretty easy. All we're being asked to do is identify alpha and beta in the following expression, which is the right side of the formula for cosine alpha minus beta. So they already have the equation pieced together. All we're doing here is figuring out what alpha is, what beta is. So I know that alpha always goes first. So 155 is going to be alpha. Beta is going to be 35 degrees. I think if you want to really understand what's going on here, how this would be combined into just one trig function, you could say that this is going to be cosine cosine 155 degrees minus 35 degrees. If you want to take this further, you can, but pretty much all you need to say is what alpha is, what beta is. If you don't know those two values, then you're really going to be struggling here. But this is a really important example to understand. I'm actually not really going to explain too much here because it's kind of the same idea. Alpha is already given to you, beta is already given to you. You know that this would be combined together like this. So if you really wanted to take this one further, you could just say this is cosine cosine 5 pi over 18 minus pi over 9, then be done with it. So these first two are super easy. There's nothing that's really being asked of you. It's really just to understand where's alpha, where's beta, and keep it going from there. We then start to complete identities with cosine of x minus 5 pi over 6. So I know that just based off of this, I know that alpha is x, beta is 5 pi over 6. I know that we're subtracting and it's a cosine expression. So based off of the first slide that was in this video, I know that I'm going to have to be using the following equation. And I know this again because of two things. I know that it's saying it's cosine. I know that it's subtracting. So whenever I'm subtracting in parentheses with two angles, and I'm using cosine, we can expand this into the form seen here. Cosine of alpha, cosine beta, adding on sine alpha, sine beta. So notice that we use opposites here just with cosine. So if I fill in accordingly, instead of cosine beta, I'll put 5 pi over 6. Instead of sine beta, 5 pi over 6. Where I see students trip up the most is finding what these values are. So cosine alpha, you could leave that as x, or I'll actually do that. I'll rewrite x in here. But as far as finding cosine 5 pi over 6 and sine 5 pi over 6, you should draw this out. You should be using the unit circle. You should know how to go for these. If you don't, ask me a question or email me or look up some resource that's going to remind you of what you need to do. So I know that 5 pi over 6, if I break up the unit circle, I know that I have a denominator of 6. So I'm going to break up this first half of the unit circle into six keys or 6 slices. So I'll cut here, cut here, cut here, cut here, and then I'm traveling 5 units around to get to here. So 1, 2, 3, 4, 5. This leaves us left over with pi over 6, which you can rewrite to 30 degrees. Using special right triangles, you should know that your x term here is going to be negative. So across from 60 degrees, this has to be negative square root of 3 over 2. This is a really important factor, but think of this like the unit circle. If it's to the left of the origin, the x-coordinate's negative, your y-coordinate can stay positive, and your radius is 1. So if we take this further, cosine is going to be the adjacent over the hypotenuse. So I know that this is going to be negative square root of 3 over 2 over 1. And then take this further, sine of 5 pi over 6. I know that that's the opposite over the hypotenuse, so this is going to just be 1/2. You could just leave your answer like this. I know that for the version that I gave you, it is multiple choice, so if you want to look into that deeper, you can. The way that they rewrite it is just by factoring out 1/2, because 1/2 is seen subtly or in a subtle manner right here and also here. So that's how they may rewrite it. If you left your answer like this, I'm content with it personally. Both ways work just fine. And I'm content with that. Good. This now has us working backwards, giving the expanded version where we have sine 20 degrees. So we have sine of 20 degrees multiplying with cosine of 40 degrees. We're adding on cosine of 20 degrees and also sine of 40 degrees. Let's amplify this so we can see it a little bit more. A little bit better, right? So I know that we are adding, I know that it's sine times cosine, so I know the only original trig function that uses sine multiplying with cosine is going to be sine. I know that since we're adding in between, this is going to refer to adding the 2 angles. I know that alpha is going to be this first angle here of 20 degrees. I know that beta is going to be 40 degrees. And so this has you just evaluating all the way to the end. If you want to evaluate this, go for it. But the whole idea here is that you don't have to go real crazy and do all this. You can just simplify it just back to its simple, original trig form. If we combine 20 and 40, sine of 60. Take sine of 60 degrees. This is a pretty common function that's used. You could just say that this is going to be square root of 3 over 2. If you're not convinced, you could sketch out a special right triangle like this. But I'm pretty confident that this is square root of 3 over 2. So that's what you need. Just writing sine of 60 degrees is not enough. You want to take it further to an actual answer because you're totally capable of doing that. We saw problems like the following in the initial 5.2 video, where we had some function that we don't really use too much, but we can combine two functions that come up a lot to try and match up to this. So if you're not too sure on what angles to use, fall back on what you've seen in the unit circle and think about how you can end up at 105. Two options that work here are going to be the following. Voila. I know that 45 and 60 add up to 105. I know that I would have to add them. I'm then allowed to just expand this identity accordingly, where I know that if I take this as alpha, this is beta, if I map out the rest of that, well, I got stuck on this, so sometimes I need to remind myself what I need to do. So let's check. If I use sine of alpha plus beta, I know this is sine of A and then cosine of beta. And then I'm adding on cosine A, sine B. So this is if you're not too sure how I piece this together, look back at the trig functions, but they should totally make sense. I'm going to run through these because these are values that you should know how to get, and the trig functions that you would be using are pretty simple, just basic quadrant 1 special right triangles. So this is square root of 2 over 2. This is 1/2. We're adding on square root of 2 over 2. Sine of 60 degrees is square root of 3 over 2. If you want to combine this all together into one answer, I think that's a good look. You could say that this is square root of 2 over 4. Remember, multiply across. You're then adding on square root of 6 over 4. You can then combine the numerator, but don't combine it to square root of 8. Just leave it as square root of 2 plus square root of 6 over 4. Done. It's not a decimal, which was a goal of ours, to not write decimals, because who has time to write all of those digits? This actually is a little bit more sound and the better option, so that's why we keep aiming for these. It's because we don't want decimals. Who wants that? I'm going to speed run through this. I made a little bit of a blooper in the first round of this video, so I'm going to have to go back and do this again. I'm going to do this a little quickly because class starts in 2 minutes, so let's see what we can do. I know that this is going to be subtracting. I know that this is sine because it's sine then cosine, so, and I know I'm subtracting, so this is straightforward like this. Finding sine of 240 degrees, if you use the unit circle, you're going to map all the way around. This is 180. But you have to keep going to 60 more degrees. It then creates a 60, 30, 90 that in the third quadrant like this. Sine in this scenario is going to be the opposite, negative square root of 3 over 2 over 1. So negative square root of 3 over 2 is what you need. Notice I used the unit circle to map this out. I kept going after 180, and then I kept going to 240. That's what you need to do to be successful on this one. We have cosine, then cosine. I know I'm going to use a cosine term where this is alpha and this is beta. I know that we're subtracting in between, so I know that I want to be adding on these two angles. 20 degrees and 40 degrees gives me 60 degrees. Cosine of 60 degrees is going to be 1/2. There you go. Things that are going to help you out looking back at the 5.2 video. A calculator may help, but really not a ton because most of this is using the unit circle and those fractions that you've been using quite a bit. Special right triangles are going to help you out a lot. Looking at this again and again, looking back at the original video will help you out. We solved 12 example problems. You also have Math Excel problems, which should have helped you out. So there are a lot of resources there for you. I hope you enjoyed the video. If you have any questions, shoot me an email. Well, now that I'm done the video, I don't need this anymore, so